What's up, everyone? This is LeetCode 208, implement trie, prefix tree. So a trie or prefix tree is a data structure used to efficiently store and retrieve keys in a data set of strings. There are various applications of this data structure, such as autocomplete and spell checker. And we have to basically implement the class, right? Like the trie object, the insertion of a word into the trie, returning true if the string word is in the trie, or false otherwise for the search function. The starts with function, which basically we have to check if there is a word inserted already in the trie such that the prefix that we're given exists in some given word, right? I recommend you click this blue link here and actually read the Wikipedia article. I do view this problem as a knowledge check, honestly, where I think if you understand what a trie is, implementation isn't going to be too hard. I think the problem is, like, if you don't know what a trie is, how are you actually going to do any implementation, right? So you have to know what a trie is before you attempt this problem, so it's actually understandable, right? If it's a data structure you've never seen, of course, this problem is going to be hard. So make sure you just look up and read on what a trie is, and the problem will be a little bit easier to implement. Just even if you don't know the implementation, but as long as you know how the trie works, it'll be easier to implement. I'll still go over how a trie works, but I do recommend you read on your own as well, just so in case my explanation is not that great. Okay, so here's a trie, right? So it's a data structure for storing and retrieving strings. Okay, so for example, we have a starting node, right? And then we have a the starting letter, right? And we in the starting the starting letter will have children, right? And at a given node, we're gonna have a variable called, let's say, end of word. I just called it end here, and this is a Boolean variable, and it'll be true or false. Now, true represents that we have a word, right? So, for example, this R is true. Why? Because O, R, that's a word, right? Or. So this is set to true. Now, generally, these ones, I didn't explicitly write it, but these technically do have it also. They're just set to false. Because, like, O is not a word. O-R-I is not a word. So this would be set to false. O-R-I is not a word, right? So, we can keep going down, right? If we have origin, right, this would be set to true at this end because this is a word at this point, right? So O-R-I-G-I-N, right, origin. So this is a word. Here, for example, right, we have wait. That is a word, right? So this would be set to true here because at this point we have a word. But we can also keep going down. We have other words in the trie, right, like waitress, which is also a word, right? That's kind of the gist of how a trie works. It's not too complicated, but like again, if you don't know what a trie is, you've never encountered it, it might be slightly confusing, but I hope my brief explanation is sufficient. So we have to implement this, okay? Now, the way we're going to implement this is we're going to create another class, okay? We're going to say class trie node, and this is for the actual nodes, right? And remember, the nodes can have children, right? And it'll have a variable called end of word, which initially is going to be false. My color coding is not working. I think the code's really slow right now. Let me refresh. Okay, there you go. So initially, right, a node is gonna potentially have children. And initially the end of the word is false because we don't know if it's actually a word or not. For when we do like an insertion of a given node. Okay. Now, and as far as the hash map goes, really what this is saying is, right, for a given node, the key is basically the children, and then the value basically is just the trie node. And this is just for fast lookup, right? So when we say if character in, and then we do whatever, something dot children, we're basically checking if there's a specific character that's key in the hash map. So for example, right, when we're at this a, let's say app is in our trie, when we do a.children, right, we see that we have p as a child node, so we can keep going. So if we're looking up the word app and it actually exists, it makes like our lookup a little bit faster and easier. Okay, I hope that explanation is okay. So yeah, so we're gonna initialize it, just call it root, right, and we're gonna make a trie node. Okay, now I'm gonna explain the insertion here. We basically when we're inserting into the try, like let's say we're inserting the word Oreo, right? We're gonna start here, okay? Now the orange, let's say, is the word, the letters we already have. The blue is the ones we actually have to insert, right? Because when we go here, O is already in our try, so we don't want to insert no, right? So we just keep moving forward. R is already in our try, so we don't want to insert. We just want to keep moving forward to this R. Okay, now we don't have an E though for Oreo, so we actually have to insert the E and insert the O. So basically, we have to check the child nodes of what when we're at a specific node, we need to check the child nodes to basically check, do we just move forward or do we actually have to do an insertion? Because we don't want to do an insertion into our try for a specific word if the letter already exists, right? So we're going to say, we're basically going to start at the top of the try, obviously. So we're going to say cur is equal to self.root, right? Cur is our variable. Because obviously when we're doing an insertion, we need to check from the top of the try. So we're going to say for char in word, okay? We're going to say if char, if char is not a child of where we currently are in the try, then we can create that node, right? So we're going to say if char not in children children char, then we create the try node. Okay, I'm going to explain this just so you kind of understand what's happening here, right? So remember, in our hash map, the keys are the child, are the in the hash map, like when we're at a given node, right? The key in the hash map is the children of that given node. The value is just the try node. So technically, the value in the hash map, you can think of it kind of like a placeholder. It's really not that important. The key is what's important, right, for fast lookup. So when we're at a given node, the keys are the children, okay? That's why I say if a char is not a child of where we currently are in the try, then we need to do an insertion, right? Right? That's what this is doing. So for example, this part here, this if statement is basically when we're at this R, we're inserting Oreo. E is not a child because it doesn't exist anywhere, so we actually have to insert it. Okay, and that's what we're doing here. Now here's where we move forward. Now, when we move forward, there's really two cases that cause this, right? One is the child already existed, or two, the child didn't exist, but we created it so we can move forward, right? Because we're still in the for loop, right? So what I mean by that is like, when we're at this R, we can go to this E, right? After we create it, we can move forward so that we can check the children of this node. Now, if this E was already in the try, then we can just move forward without inserting it. So again, this is just for moving forward basically in the try. Continue to move forward. Either the child node doesn't exist and we move forward, or it doesn't exist and we insert it and then move forward, or it does exist and we could just move forward because there's no point in inserting. Okay. So yeah, that's basically it. That's the insertion. It's pretty simple. And then at the end, obviously, we want to make sure that we identify that we're at the end of the word because we inserted a word. So we want to make sure we signify that in our try by saying, hey, we inserted a word. So at the last node, let's set that node to end of word as true. Okay. Now the search here is, it can be a little bit complicated because these are going to be the same function. It's really just what we return. Okay, I'll explain in a bit. So when we search for a word, we basically kind of want to do what we did in insert, where we want to check if something exists or not, right? So again, we want to start at the top of the try, right? Start at the top of the try, right? Because we want to search a word. So obviously we're going to do the same thing. We're going to start at the top of the trie. Okay. So we have an input, right, called word, and we want to go character by character and check if those are all in the trie. If it is, that's good. If one of those characters are missing, it means our word is not in the trie, doesn't exist. So we just return false. So we're going to say if char not in children, right, return false. And again, like why can we do children, right? It's because we're technically starting up here, right? So let's say we're looking for the word Oreo. Okay, we're looking for this O. We're doing, okay, does this have any keys in the hash map that are O? Yes, because remember, the characters are keys. And the value from the hash map is just the trie node. It's just trie node. And again, trie node is just kind of placeholder. The key is actually the important thing, which is the characters. So O does exist, so we can move forward, right? We can move forward. So now we're here. Okay. Does R exist in the hash map? Yes, it does. We can move forward. Boom, boom. Now let's say this insertion wasn't here. Does this R have any children that are E? Well, no, it doesn't. So then we would return false. Okay. Yeah. That's how that would work. That's what we're doing here. Now we could have an else case where it does exist, right? In which case we just want to do what we did up here, which is what we just want to move forward, right? So we're going to say children. Okay. Now, here we want to return end of. Now you might think, okay, we never returned false in this for loop, so why would we not just return true here? Why do we have to do this? Well, let me give you an example. Let's say our trie has the word toaster in it, right? But we're searching for toast. Okay, so the way our algorithm would work is we'd go TOAST. We found toast. Well, if we return true, we would say, okay, toast is a word in our trie, but it's actually not, because the word here is toaster, not toast. Toast is not a word in our trie. So we check this T and we check this end of word variable, and it would be false, right? Because again, toast is not a word in our trie, only toaster is. And so this would actually return false, which is what we should get, because again, toast does not exist in our trie. That's why we do this instead of returning true. Okay. Now down here is basically where we would return true, right? Because we're only searching for a prefix or like a substring. So when we're down here, and let's say the prefix is toast, right? But our trie only has a word toaster. It doesn't matter if toast is not a word in our trie. We're only looking for a prefix or like a substring. Does the substring toast exist in toaster? Yes, it does. So we can return true, right? And so that's the difference between these two functions. They're very similar, but they're slightly different, right? One, you're looking for the actual word, and one, you're looking for the actual. Okay. What is this? Line 2. Self is not defined. Oh, I have to put this in a function. I forgot. That's actually my bad. Let's say self. Move this over. Boom, boom. Should be fine. Line 40. Oh, slightly. I think I typed too fast. I put C-U-U-R instead of C-U-R-R. Oh, and again, here, the input is not word. It's actually prefix, so be aware of that. I'm going a little bit fast. I'm sorry. Silly mistakes. Again, yeah. I copy and paste it, so obviously here, we're gonna have the same little bug or slight mistype. Yeah. This should work, right? Except for my slight mistypings. My apologies for that. So yeah, it worked, right? So here's the code, right? You can pause at any time. Here's the rest. So yeah, implement a trie. It's not too difficult. Just make sure you understand how we're actually using the hash map, right? The children are the keys in the hash map. and we're using that for fast lookup, for when we're searching for a word or whatever, or inserting or looking for a prefix or whatever. But I hope this helped. Again, I don't think this problem is too hard. It's just a knowledge check, and then you can kind of understand how the implementation works as long as you know how a try actually works. So I hope this helped, and I'll see you in the next one. Peace out.